With our new open source project, Kommodity, it's a matter of a small switch in one value and maybe a few like credentials of how to connect to that cloud, and boom, you're going.
The cloud became a thing around 2010. The idea was essentially that you can get infrastructure very, very quickly, and that you have an API to interact with it, kind of an interface. And that was very different to traditional infrastructure where you would send a ticket, you'd wait a long time, and then you would get something at the end of the day. Wouldn't necessarily work depending on the organization and the maturity of that. But yeah, it is very different, right? Because suddenly a developer is empowered to just get something immediately versus waiting for their own organization. And that was kind of the big shift there. And that's what's driven the adoption. But now we see kind of a little bit of the aftermath of some of the hyperscalers, right? So there's the lock-in part that's incredibly painful for some organizations. And there's a lot of different dimensions that lock-in can hurt you, both in terms of technology choices, but also scalability and capacity management, those kind of things. I mean, there was a big hyperscaler, actually multiple, had some major outage recently, and it's affected the world quite a bit. And it's because a lot of organizations are locked into those hyperscalers.
Which one was it?
It was two different ones.
Yeah.
And I mean, I think the reason why those hyperscalers has become so popular in such a short amount of time is that it's incredibly easy, even if you're not that technical. Maybe not you, Jack, but even if you're not that technical, you can very easily deploy an application within very short amount of time. They will put on a lot of assumptions for you, and that's also what you've heard. Like this, cloud bills are exploding, and that's because people are not putting requests or limits of how much capacity you need on the hyperscaler. So it will just increasingly expand with the consumption. So if your product suddenly goes viral on social media or whatever, your cloud bill can explode in a matter of seconds because you haven't put any limits on how much you want to spend on the cloud. And even worse, there are companies also in Denmark where the whole infrastructure is built on very technical components that only exists in one or two of the hyperscalers, which means that if the cost model of the hyperscaler changes, you have nothing to do but pay the bill. Otherwise, you're out of service.
When we talk about in the healthcare space, are these the same concerns that people are having? Is that the same just in every industry, or is it a little bit different for us?
I think specifically in healthcare or GDPR-related industries as healthcare with P&I data, I think it's not only the cloud cost that's the problem here. It's also the security and the whole data aspect of sharing data to US or sharing data outside of your own country, even just in the European Union. I mean, we see countries in European Union that has legislation now where data cannot leave the border, even if it's within the European Union, not only to US or to China or whoever out there, but actually within the European Union, we don't even trust each other anymore. I think that's a much bigger concern in healthcare and industries like that than necessarily how much your cloud bill is.
So why don't people just buy a bunch of servers?
Because it's hard. It's hard to do all the cryptographic stuff, all the encryption of it, the security of it. I mean, like, it depends like which kind of frameworks you fall into, right? But a lot of companies, they can just get away with like, oh, we restrict physical access and that's it, right? But with the health information, you cannot just guarantee that, okay, if we lock it, then it's fine. Like you might lose some IP, right? If you're not in that regulated industry, and oh no, there's a patent now that's maybe like 20 years old and that existed on a hard drive, wasn't properly disposed of. But you can't do that with health information. You don't want somebody's medical information to exist on a hard drive after that server goes out of that data center. And that's the tricky part, like getting that to work and then getting that to scale. Because one thing is the whole thing around like getting it secure. The other dimension is also then making that scale, because the whole, like, if we then add the dimension of AI into it, like getting that AI hardware is hard and it's expensive hardware. So you
So the
don't
type
just
of server needed to run AI
Yeah.
compute is different to just general compute.
yeah. It's a lot different. I mean, if you look at some of the hardware from NVIDIA, right? Then like the DGX servers, for example, um, like it's basically a graphics card pretending to be a server. It's really really crazy hardware.
There is a huge shortage in the market right now. I mean, companies like Nvidia, I mean, they cannot keep up with the pace of people needing these GPUs, and they are horrible expensive. So there are companies out there which simply doesn't have any other choice than renting the hardware, because I mean, they're not in the forefront of the queue. I mean, there are the hyperscalers out there. If they blink, they will get whatever they need, because I mean, the consumption, I mean, the amount of hardware they're buying is so huge that they cannot lose them as a customer. But smaller companies, they can wait in queue for a long time to get this type of hardware, or they might not even have the economical foundation to buy this hardware themselves and host it themselves.
The game's changed a bit because like the cloud and hyperscalers, it used to be this notion of everything is limitless. And that's kind of changed now because like if you go to any of the hyperscalers or also like some of the neoclouds and you tell them, oh, we need this amount of hardware, and by the way, we do primarily inference, um, then they'll be like, ah, yeah, but you want to scale down at night? We don't really like that, and we can't guarantee that you'll get the capacity in the morning again.
Mhm.
So, and that's a little bit scary as well.
Okay.
And there is also another aspect. Now we talked about like data security and data cannot leave the borders. There are a lot of those hyperscalers out there which doesn't have the necessary hardware available in all regions in the European Union. There are even countries out there which doesn't have its own region. I mean, there are no region called Denmark, for instance, in some of the hyperscalers. So I mean, if you were to host GDPR related data, and let's say that we had a law in Denmark stating that data cannot leave the border, you would not be able to do it in a hyperscaler. There are no region called Denmark. We are simply just too small a country.
There's something in between these three massive hyperscalers and buying a bunch of servers yourself. And there are a lot of available servers that would be able to, again, maybe not train the models, but be able to run them. Is that right?
They are, but there is a bit of sprawl in the ecosystem, and that's what we're trying to solve with our open source project Kommodity.
So when we use the term commodity, what are we talking about?
So Kommodity is an open source project that we started at Coty about 3-4 months ago. And it's basically a single binary that's built on top of Cluster API, and that Cluster API helps you deploy cluster. This helps you provision your infrastructure so that you can deploy your Kubernetes cluster. It's built on top of Talos, so we're deploying Talos Linux, Talos clusters, and it's super powerful because we can support basically any infrastructure provider. We can support the big hyperscalers, but we can support some much smaller ones. We can run on-prem, so we're using OpenStack, for example. So it's very extensible. It's basically plugins that you integrate.
Yeah. Why is it called commodity?
So it's kind of alongside the trend of like taking an existing word and then putting a K in front of it to kind of give it the Kubernetes spin, and kind of that's why I called it commodity, because the idea is to commoditize infrastructure, networking, and all of that, and to have that abstraction. And Kubernetes does some of that, but this is more like on a deeper level. Kubernetes does that for the containers, but we need to do it for Kubernetes. So that's why it's called commodity, to commoditize infrastructure.
Beautiful.
Right now, if you were to automate your deployment to an infrastructure provider, many companies, including ours, are using Terraform. Terraform, it's a descriptive language, but it has this limitation that you're writing the code against that specific hyperscaler. We have thousands of lines of Terraform to deploy our infrastructure to one of the hyperscalers. So the problem is, I mean, and we are not even that dependent on that specific hyperscaler. We don't use very specific services niche to that hyperscaler, but we still have thousands of lines of code to deploy our infrastructure. And I mean, our infrastructure from that point is actually pretty simple because we have built a lot of our services into the Kubernetes cluster. So as soon as the Kubernetes cluster is deployed, it's deploying itself underneath. So I mean, you have many other companies out there which I've also worked for that has many more lines of Terraform that we have currently in Cordy. But even if we were to switch to another hyperscaler or a local hyperscaler in Europe, it would take months to rewrite all of that code because you have to rewrite it specifically to that other infrastructure provider. And what Paul is saying is that with our new tool, with our new open source project, Kommodity, it's a matter of a small switch in one value and maybe a few like credentials of how to connect to that cloud, and boom, you're going.
Yeah. So when you're talking about the vendor lock-in before, it's not about contractual lock-in. It's also technically just really bloody hard to.
It is mainly technical. Yeah, there are some contracts that you sign for quotas to be able to make sure that you get the resources, but the technical level of switching from one infrastructure provider to another in the current landscape, it's a whole different beast.
Could I do it, Stefan?
I mean,
maybe.
I think so.
ChatGPT can do a lot for you.
I mean, if we zoom out a little bit, right? You saw like a lot of companies that were running on Windows servers back in the day, and or even like some of the mainframes, like AS400s. That was before my time, even. And the interesting thing is that this switch over to Linux, like that was one big generational shift in infrastructure. And kind of we're seeing a similar thing now where people look at the hyperscaler setup and they realize that, oh, we need some kind of abstraction in between. We need that layer that is uniformly agreed upon. And kind of people have an implicit understanding that most of the time that's Kubernetes. And Kubernetes can give you that abstraction. But then there is a million different ways to do Kubernetes on those hyperscalers. And that's kind of the problem that we're trying to solve, and all the little problems that the hyperscalers usually solve for you, like identity, encryption, storage, databases. And that's where it gets really, really interesting, right? Because you don't really build on top of some of the fancy things that the hyperscalers have, but you go back a little bit to the basics and the open protocols, things like OpenID Connect or IDC. You can do a lot of really, really fun things if you fully lean into that protocol. And that's really, really cool then.
And if you then, on top of that, add the layer of AI and GPUs into that picture Nicholas just explained, then it's first getting really tough.
Because I was going to ask, I mean, you guys have been working on this project for how long now?
4 months,
3
I
months,
think.
yeah, 4 months, I think.
Okay.
Yeah.
And it's been pretty easy?
No.
Yeah.
No. I mean, yeah, Kubernetes is open source. It's built voluntarily. If I recall correctly, it was Google that invented Kubernetes first. It's open source. There are thousands of people out there contributing to it. So I mean, you cannot really complain if there is something that's not documented. I mean, usually documentation is quite good in Kubernetes and in the whole CNCF open source world. CNCF is this Cloud Native Computing Foundation, which is an umbrella on top of most open source related to Kubernetes. And usually documentation is actually fairly good. I mean, remember, people are doing this voluntarily. I mean, yes, there are companies backing some of these projects, but a lot of the work are also done voluntarily. But I mean, the places we have gone in the Kubernetes code to figure out how to do this, I don't think it was intentional that you should do this. I mean, it's a world where nothing is documented.
And there's been times where we truly thought that, we might actually not be able to do it.
I remember a meeting with the two of us, Nicholas, where we were like, yeah, it's not gonna work.
You almost gave up.
Yeah. We were
really close.
We were really close. I think we were 2.5 hours in Henrik's den, and we were like, we were very close of throwing the I mean, the white towel. I think it was not because we didn't thought that it was possible to do. It was just because it was so tough figuring out how to do it, because I mean, there is just no documentation out there.
And it's also because we had very high requirements, right? The fact that we want to bundle everything together, then we had to step up and find a solution for that, right?
Why do we want to bundle everything together?
Basically, so I said we were building on top of cluster API. This cluster API thing, you need to deploy it in a Kubernetes cluster. So it's basically a Kubernetes cluster that helps you deploy other Kubernetes cluster. But we don't want that first initial Kubernetes cluster. What if you want to deploy the new infrastructure on something that don't has access to that? We wanted to really minimize the size of Kommodity to just a single binary. And a binary you can deploy anywhere.
So basically, it's the chicken and egg problem. What came first? Is it the chicken, or was there an egg initially?
Can we solve that on this chat?
I mean, from a Kubernetes infrastructure point of view, that's what Kommodity solves. I mean, there are no chicken and egg because we don't need the Kubernetes cluster to deploy another Kubernetes cluster. Now we have everything, as Paul says, bundled into one binary, which can run on your local machine. I mean, I've had Kommodity running on my local machine, deploying clusters to hyperscalers directly from my local machine. You can run it anywhere. You don't need this. What's in the Kubernetes world is called the bootstrap cluster. So what you usually do is that you set up a cluster manually to help you deploy other clusters. But I mean, at the end of the day, I don't want to sit and do ClickUps. I mean, I'm writing code. I'm not sitting and doing drag and drop and selecting boxes in a UI to be able to deploy something else. And a lot of developers out there don't want to do it. Yes, we could write some Terraform to do it, but then we're back to square one again. What if we want to move it to another infrastructure provider? Then we have to rewrite that Terraform again. Yes, it's a minimal amount of Terraform, but it's still redundant work to do the same again.
The only dependency that Kommodity has is a database, which you can find anywhere, right? Let's say a Postgres database. So even if you need to run in an air-gapped environment, completely cut off from the outside world, all the resources that Kommodity needs, it has it already. So it's extremely simple to deploy.
Not to be funny, but why did you have to build it yourselves? Like why not?
Because no one else has built it.
Why not?
I mean, there are a few other companies out there which has done it too specifically. And I was attending KubeCon last year in London, and one of them gave a talk on how they did it. They just haven't chose to make it publicly available for anyone else to use it.
So is that one of the key differences here? You talked about at the start that Corty's own infrastructure has been running on one of these hyperscalers as well. So just as an independent business issue, we've wanted to get that flexibility to shift if we needed to and whatnot.
But actually, it's more than that, because we at Corty are seeing customers and partners out there which are running in regulatory countries. So it's not only for our own purpose; it's also for our partners out there which are based in countries where you aren't allowed to run on these hyperscalers.
I want to talk about that as well, but just to make sure that I understand that the making it open source, you mentioned that you went to KubeCon and there are other companies that have built similar things but decided to keep it behind closed doors and keep it for themselves. And I understand the reason we would open source it partly is because we get other people to work on it and maintain it. And for us, there's a benefit there. But are there also practical reasons why we needed to be the ones who were building this and then making it more open?
Well, this is not necessarily company dimension, but it's a sustainable thing to do. And I mean, if we want to set ourselves apart as being the European leaders on something like this, then we got to make the first step somewhere. And I think this gives the ability to create a general community around this, not just European, but for everyone, with a solution that can solve a lot of problems. Because like we've solved kind of the abstraction towards the applications, but we've not solved the kind of the abstraction towards infrastructure. And that's what we're trying to solve here. That kind of everybody can build their own cloud on their own terms. And I think that's what's really, really powerful, because infrastructure should be easy, but it's not today. It's hard.
I mean, at the end of the day, we are in Corty also very dependent on the whole community of CNCF. A lot of our products internally are built on top of these products. So, I mean, you could also ask yourself, I mean, why shouldn't we contribute back to this community and help the other ones that has helped us? I mean, why do we need to spend countless hours, man hours in each company to reinvent the wheel every time if we can build together?
Also, we've been paying the complexity tax for a long time. And it's at some point you got to realize that that's not sustainable to do in the long run.
What's the complexity tax?
Kind of the complexity of being locked in somewhere. So you got to do that mental shift. You have to then train engineers on this bespoke new setup because every company has a different flavor of doing it. And also, like, in terms of like making your engineers happy in the long run, that's not going to make your engineers happy. So your engineers want to deal with interesting problems, not figuring out, okay, a circle is a square over here. So
Mm.
that's also kind of an important dimension to it.
Mm. And then you mentioned a couple of times now, Stefan, that there's we have customers who have strange restrictions. For example, in Switzerland, where they have, as I think you mentioned, they have like a data sovereignty regulation for the country, meaning that like it kind of just it's not good enough that it stays within the EU. It specifically needs to stay within Switzerland. And in that case, there aren't actually hyperscalers with the right. You would need to help me out here a little bit, but with the right sort of encryption GPUs or encryption capable GPUs even available to them, whether or not they wanted to
Pay the bill.
Yeah, exactly.
Yeah.
Like that vendor lock-in or not, then it's just not even physically possible. So that's sort of a demand-driven reason as to why you three got busy and trying to build this difficult thing. But it is a little bit beyond that now, right? As I think you've established, it's no longer that you need to come to Corti if your particular hospital or healthcare organization is based in a country that has these strange regulations, then you need to come to us. This is now appropriate or beneficial to all sorts of companies, including those that still want to use hyperscalers but want the flexibility.
If you really want to run in a hyperscaler, there is this term of confidential compute. So you can actually run in hyperscaler, ensuring that your data is fully encrypted both in transit, at rest, and in memory. But that requires confidential compute, which is very costly to run, especially if you need GPU power, which you need in the AI industry.
Gets a lot easier when you then choose to run an infrastructure that's not owned by a hyperscaler, because suddenly you're not required to encrypt the data in processing. You still need to do it at rest and in transit. And of course, that's the best practices to do it. But that means that suddenly it doesn't become trivial to do it, but it becomes a lot easier because you don't need a lot of the dimensions of attestation and kind of infrastructure trust, because that gets very complex, and there's few cloud providers that get that right.
Yeah. So your point is that the regulatory, like the reason that you would need to have this confidential compute in processing, the reason that you would need to have it encrypted during processing as well is due to regulation. Mm. That if the confidential healthcare data is leaving the country, then it needs to be constantly encrypted so that in those other nations nobody would be able to access it.
But even in Switzerland. So if you run on infrastructure that's not owned by a Swiss company, then you need to run it in an encrypted fashion. So
even if the server was based in Switzerland, but it's owned by...
Yes, because like there's the Cloud Act, and people don't really feel comfortable about the whole dimension of, if somebody has a mandate, they might be able to get our data one way or another.
With Kommodity, you would actually be able to run your GDPR data in an hyperscaler without paying the bills of a confidential compute hardware, because we have implemented this functionality of encrypting the data into Kommodity. So the clusters we are deploying, so you could actually get virtual machines that are not running on confidential compute, because we are taking care of the encryption of the data within Kommodity if your cluster are deployed by Kommodity.
Maybe we can talk a bit about Talos, right? Why we chose Talos?
Talos.
Yeah.
So it's I think you can expand on that, but it's an operating system that is running Kubernetes. And basically, it's the safest way ever that you can run Kubernetes. You cannot log in. Like once you have set up your nodes, your virtual machines, there's no way for anyone to get in there, right? There's no SSH, there's nothing. So it's really all made probably the safest way to run Kubernetes, right?
Yeah, it's an operating system tailor built for Kubernetes, and it's of course running Linux. And it's really interesting because they made a lot of design choices that allow you to both extend it, but also to like really do it in a secure way. So while you have other operating systems, and we do love them, I mean, I run them at home like Ubuntu. It's I grew up with Ubuntu and Debian, but they don't necessarily work that well in a production environment because you need to patch them a lot more because they have a lot more things on them. They come more batteries included, but that also, yeah, it comes with some trade-offs, right? So if you can get rid of some of those batteries that you don't necessarily need in a Kubernetes environment because everything is a container, then that gives you a lot more ability to do some other nice things. So disk encryption suddenly becomes a lot easier because you can do some integration there. That's what we're building into Kommodity as well, kind of that integration with the disk encryption over the network. So that's just one of the interesting dimensions.
And another thing is the whole zero trust architecture we build into Kommodity as well. So as Nicholas and Paul mentioned, Talos provides the ability to run an extension when a machine tries to join the network or tries to join the cluster. We would provide some custom code written in Kommodity. It's an extension to Talos that runs within the machine before it even joins the cluster. It will fetch a lot of information about the machine. It will encrypt it using the TPM, which is a small cryptographic device inside the virtual machine, to prove that it's this machine who have actually uh, measured these different measurements about the machine. It will send it over to Kommodity, and when Kommodity gets a request from the machine to join the network, it will validate all of this information that this is actually a legal machine that wants to join the cluster, and it's not been tampered, or it's not been intercepted, or it's not like a man in the middle trying to make a fake machine to join the cluster and thereby creating harm in the machine, which is essentially what confidential compute, how that's implemented in the hyperscalers.
Okay. So what I understood, we might cut this because I actually just want to clarify. You have this data which you want to protect. You don't want anybody else to be able to get it, anybody that's not sort of part of the system. And one thing is having that data be encrypted so that even if you did get access to it, it's useless.
Yeah,
that you can't.
it's bonkers.
And what I understood is, maybe I got this wrong, but what you're talking about is like actually just making it very difficult for any third party or sort of external computer to access it in the first place. Which is
Not really to access the data, but to join the cluster. I mean, so a Kubernetes cluster is usually, I mean, it would be useless to have a Kubernetes cluster with only one node, right? So usually your data is distributed on many different machines and many different nodes. And what we prevent by implementing this, what we call attestation extension, on top of Talos, is that another node from outside cannot join our cluster and by that get access to the whole cluster. What we are trying to do with Kommodity is making secure infrastructure available for everyone.
what happened a month and a half in? What was surprisingly difficult about it?
Maybe let's hear from Paul, because we were running for 1.5 months or so when Paul joined and got
You joined right at the
thrown right into the den.
Yeah, that
Wow.
was
So maybe let's hear.
that was a fun start. No, for sure. I mean, I had some experience already prior with Kubernetes, but I had been using Kubernetes. I had been using the engine. Now we had to basically open up the engine and see what's happening inside. And like Stefan said, nothing is documented, and yeah, you just have to read through the code and try to make sense of it. But what was hard, if I take examples, I mean, all the aggregate. So if you look at Kommodity right now, it's like what, 5 servers running inside. It's the whole aggregation of different types of server that we have running in there. For me, the whole in architecture of which server is calling what and so on, that was really the hard part, and still is, for sure, but the hard part for me.
Yeah, I think Nicholas and and myself, our mindset from the beginning was that we want, because it's so hard, we want to make it as easy as possible for people to use it. So we have done a lot of architecture to make sure it's very easy. And one of the things which was surprisingly hard as well is that, as Nicholas also talked about, Talos is doing this live decryption and encryption of the disk when it joins or rejoins the cluster. And that requires another protocol than a regular API like we expose in Cordy. This is running on a technology called gRPC. But for the fun of it and to make it as easy as possible to interact with Kommodity, we want the regular API server and the gRPC server to run on exactly the same IP address and exactly the same port. So you don't have to do like all of this nasty if else in the code and make the code ugly just because it's running on two different ports as it would do in any other service out there. So making this aggregated server that can actually expose two different ways of communicating on the same port sounds easy, but definitely not, because it's not built into Kubernetes. Kubernetes is natively talking HTTP and talking REST. So what we're doing is actually we are deploying within Kommodity, we're deploying a reverse proxy on top of Kubernetes that handles the request, and then we bundle that proxy together with the gRPC server into one single server that's surfacing, because Kubernetes doesn't natively talk gRPC, or you cannot attach two different services on the same port.
And why do all this painful stuff, right? Like one thing is all the if and else statements, right? But the other thing what we talked about is like, what is the target deployment model? So like this kind of management plane that Kommodity is, we want to make it as easy as possible to run that in your own infrastructure where you consider it to be safe, right? And that can be, it can be a hyperscaler because it's very easy to move that thing because it is a single binary with just a database dependency. But you can also choose that, okay, my root of trust, I want to have that in my data center. I want to protect it with my life. So, and then you can also do that. And it's very easy to do that. But that requires that you make sure that there's not a lot of external dependencies to it. And the more ports you add, the more routing and networking and all of that stuff you need to do. So the more of that complexity that we can move into this binary and kind of hide from the consumer of the application, the better it is. And then that's kind of the part that's really hard, like what Stefan talked about, kind of multiplexing between gRPC and HTTP. That's where it becomes like really funky. And then yeah, it's exciting stuff.
The way that we have orchestrated the provider model in Kommodity also makes it able to run in a completely air-gapped environment, which means an environment where you don't have access to network anywhere. So everything is baked into Kommodity. All the CRDs, which are these custom resources that defines how a cluster is deployed through Kubernetes, is baked into Kommodity as well. There are different toggles that makes them available or not, so make a slimmer version of Kommodity when you're deploying it, but everything is baked into one single binary that can run completely without any network outside network available.
I mean, we've been bashing Terraform a little bit, and I think I want to double down on that a little bit.
Cool.
So I think to set the frame a little bit, like I talked a little bit about APIs and infrastructure and how that's kind of changed the landscape, and Terraform solved a lot of problems there, but there's still a lot of problems that Terraform didn't solve. You still have like when you look at a lot of the tutorials out there, and of course like they're not meant to be production ready, but these tutorials rarely tell you kind of how do I abstract away some of the automation that I'm writing with Terraform from the actual service offerings that I have. So a lot of people, they will just dump a tfvars file into their repository and they'll call it a day. And then you need to copy a lot of the code, or like you just copy the tfvars file, but it's not really easily consumable, right? And there's ways that you can do that better, right? You can yank out the actual variables, put that into a YAML file, and that might be easier. But like kind of the industry has decided that that's still fairly painful. So, and then you see like the kind of more new age stuff that people do is that they fully lean into the Kubernetes ecosystem, and they even have like they're called operators, and they have these operators that reconcile and continuously monitor your infrastructure and drive it to the desired state. And that's kind of the kind of self-healing nature of Kubernetes. That's where it comes from, and that's really interesting stuff. Because people like, and Cluster API is built on that principle, right? It continuously monitors, okay, this is the desired target state, and then it drives your infrastructure to that desired target state. And is really nice because it allows you to automatically recover from failures and all of those nice things. But also it can deal with a lot more edge cases, right? Where in some of those cases with Terraform, what you experience is that, oh, there's this one little edge case that I can't solve, or this one thing where then I need to manually intervene. And then suddenly you break this whole paradigm of everything is in code, everything is descriptive, because you need to have that one little workaround. Whereas, like with controllers and operators, you have the ability to build that into the logic of the controller very nicely so that it can handle some of those edge cases. Or, like, oh, maybe in this particular case, I need to actually restart the machine and not just kill it and bring it back up because, well, we run in a data center, we have limited capacity. We don't have the luxury of just creating twice the amount of machines. And that's a really interesting thing there, that if you fully lean into this operator ecosystem, that it gives you a lot more flexibility and power in a way, because as the user of that ecosystem, you just specify, this is what I want, and then your system just kind of magically gets there. And I think that's the thing that makes me really excited, that your system just goes there automatically and you get it almost for free.
I mean, Kubernetes is built on this whole like principle of eventual consistency. The chances of the first like manifest you deploy work straight out of the box, it's like 0 to none. It will get through some stages where it doesn't work, but eventually it will work. And the good thing about Kubernetes is that it kind of doesn't matter in which order you deploy your things. Whereas on Terraform, if you haven't deployed this module, then this one cannot be. And there is this whole dependency. I mean, even just a few days ago, we needed to remove all of the things again, all of the things of a subcomponent to do it again, or we needed to run the Terraform pipeline twice because we missed one module saying this is depending on this one. I mean,
Oh yeah.
it's so dumb that you need to be so declarative saying that this one depends on this one. Well, obviously I'm using the ID from the other one, but it doesn't know how to find that reference if you don't specifically say that it's that reference. On Kubernetes, you can deploy 7 different objects, all being completely dependent on each other, and for a few minutes, it all looks like hell and red. I mean, imagine this operation like where people are sitting and watching screens and they have to be green all the time. I mean, these memes out there, and if there is one red, you need to press it and wait for it to turn green. It's just not there in Kubernetes because everything is red all the time, and boom, magically it's green.
Okay.
And no one is doing anything because it's built on this eventual consistency principle.
It's a different age. It's a different age. I think like traditional infrastructure, even like if Terraform is not traditional infrastructure, right? But
It's like it was a I mean it was a nice transition towards something better, but I mean we are through that now.
Okay.
but kind of the paradigm of traditional infrastructure is to be fully in control every second of the time. And then like, but if you run with a knife, you need to be goddamn sure that you don't trip, right? And that's kind of the thing, right? If you have a lot of control and you want to have that control, you need to be really really careful. And that is kind of where Kubernetes and like operators, they make it a lot harder to run with a knife,
Mm.
which is good. So you may trip up, but you may not as fatally injure yourself.
Mm.
I think like while right now we mentioned that we still run a lot of stuff built using Terraform. Like I expect that some of the inference clusters that we'll be running for some of the big customers that we're onboarding now, they will run on top of Kommodity. So it's going to be the engine that's going to power some of that. So and that means we'll be running it in production. We're going to see where it fails. We're going to see where it succeeds. But by the time we've been able to battle test it, and I think that's going to be really, really interesting to say that, oh, this is not just a concept car, right? But we've taken this through the mud and this is where it leaks.
Yeah.
Because I wanted to add something more on the more technical side, right? We're going to be done with the confidential compute. We're going to have integrated Cilium, the CNI, so that all the networking is done through Cilium, a super powerful networking solution. We're going to have integrated Rook,
Mhm.
a Ceph storage orchestrator.
I think we're also going to run databases on top of it potentially, right? So that's going to
Yeah.
be nice.
We're going to support more infrastructure providers, right? Because right now we can deploy clusters to Scaleway with Kommodity, Azure. I integrated KubeVirt. It took basically 2-3 days to add a new one. So hopefully more and more coming.
You showed me
Yeah.
this list once. I think
Yeah.
you've shown it to me as well. It was a very long list of providers. Why is that not just inherently covered?
Because it's basically plugins that we need to integrate. But the work to integrate them it's pretty easy. Like I was saying with KubeVirt, I had to add 5 lines in a YAML. I had to integrate their reconciler loops in a Go file. It's like a short Go file, right? And then you build up your Helm chart, add some Helm charts. It's a matter of days. And so basically, any customer that comes to us, if they pick one provider in the list, let's say Oracle Cloud, if for some reason you would want that, we can actually support it very quickly.
And I mean, why is there any engineering effort in it anyway, right? It's because we first want to test that it does actually work. And then the other dimension is also we want to make sure that we maintain this abstraction layer so that for you, switching from A to B becomes very seamless. So, and that little bit of abstraction layer is a little bit of templating, but we just need to write that right.
Yep. So previously, if you wanted to switch cloud providers or start hosting for the first time, I guess in some cases, but what was it, like a month or 2 months? I guess it depends a lot on the application.
I'm aware of a big Danish company. I mean, where the CEO got appointed by another CEO of one of the hyperscalers and saying, we are very dependent on you, and I can see that you're not depending on us, that you're depending on another hyperscaler. I mean, we could in theory just replace you with any other company or do it yourself, or you could use us. This has turned into, currently so far, it's a project running for 10 months and they are not 5% done yet.
Okay.
I mean, we're talking years of moving from one hyperscaler to another.
Years.
Moving infrastructure is hard.
It's not easy, man. They have whole teams built to support that specific infrastructure provider they were using.
Yeah.
I mean, imagine re-engineering whole engineering teams just because one guy poked another guy.
Yeah.
And I think that's really the interesting thing. Like when people talk sovereign, they often say like, "Oh, it's all about confidentiality. It's all about like stuff within borders." But a lot of it is also like, how do you build your software? Are your applications portable in terms of technologies, like the technology choices you make? Or do you integrate with this super special database that only exists on this one provider? Or do you choose to use something that's open source that can run on any different provider? So it's also like the technology choices and protocols that you lean into as a company that also has a huge effect on how sovereign can you be. And I think especially in today's day and age, as sad as it is, like that's a very relevant conversation because I mean I do consider us all humans, and I think that's how we should look at each other. And then like yeah, there's some arbitrary lines left and right, but
What do you mean? What are you talking
like
about?
the whole thing around borders, right? It's a little bit of an arbitrary concept. Whereas like at the end of the day, like I feel that's a nice thing about open source a little bit as well, that the borders kind of disappear because like you work on a particular technology and it's just in terms of like you work out in the open and you create this project and you contribute to this project. So it doesn't matter like that there's an arbitrary line and it has one label on the one side, one label on the other side, but you just work on a project. And I think that's kind of the nice thing that if you do build things in a sovereign way, then it's not about borders or anything like that. It's just about kind of independence as well. No matter if there's borders involved or not.
at the end of the day, this whole movement towards getting your data home to yourself is powered by political decisions and is powered by how the world looks like these days. So I mean, it's hugely important. And as you also said, Niklas, by the end of the day, all of this borders is just lines that somebody drawed on a map. I mean, the Earth wasn't born with borders.
Yeah, it's interesting. So even the commodity project itself, if we're honest, was born out of responding to regulation, as we talked about a little bit earlier. But the open source collaboration that is now the day-to-day for you guys, the way that you're building and so forth, your point is that's, yes, it services a current sort of political or regulatory constraint. But in truth, I think you said this, Nicholas, is sort of a new age. It's a new way of moving forward. And whether you're based in the United States of America or, Australia, the front, theoretically, the right way to build infrastructure is the right way to build infrastructure. And what you're talking about here is not building a more limited setup so as to be able to service a regulatory constraint. You're actually talking about building essentially just a better way moving forward, whether or not you need to meet any particular requirements today or be ready to meet future requirements, or you simply have cost concerns. You want to make sure that you don't end up locked into a vendor that can charge you through the roof. You have your own privacy and security concerns in terms of the data that's being processed. Whatever the motivation might be.
I mean, Kommodity is not a rage bait against hyperscalers, and that's also why we natively support hyperscalers in Kommodity, that you can deploy to hyperscalers through Kommodity. It's just the ability. What we do is not trying to get people out of hyperscalers. That's business own choice, but we want to make the flexibility such that the company doesn't get down and out because a hyperscaler choose to 10x the cloud bill the next day, and they don't have the technical capability to move to another place.
And there's also like, if you look at the cost more broadly, right, then you can look at the prices of very popular hardware. I mean, like the Hopper GPUs, the H100s, they're very, very popular at the moment from NVIDIA. And you see them in one hyperscaler being in the neighborhood of like 6,000 euros a month. And then you look at some of the neoclouds, and then like with a bit of negotiation, you can go somewhere below 2,000 euros a month. That's a lot of money. That's a big difference. And of course, you don't get like necessarily like the full features, and you might get a little bit less performance, but like that's not always the case. So it's also like, I think in a way it gives like a little bit more competitive edge to some of the neo clouds, and giving us the ability to use some of that hardware that might be lying in a data center underutilized, like more effectively. And I think I can't remember the exact numbers, but there was this thing where they made a study on how much of the compute resources that are actually allocated to projects are actually idle. And and this is not the normal idle stuff, but this is like you provision a server, and then like it's only utilizing the server for like 40% or something. And they said like it's the energy consumption of a major country basically every day. And that's crazy if you think about that. So also being able to improve the utilization of what's already out there, it's also a sustainable choice in a way.
There are resources enough out there. We're just not using them the correct way.
Yeah. I think there's a thing about commodity that's been nagging me in the back of my head for a long time. And it's kind of the like, as we've kind of built stuff on top of the cloud, and kind of in a way, in an effort to kind of fix team topologies, um, we've we've been driving towards microservices where we split up an application over the network, and we separate team responsibilities. And like in some cases that works very well, other cases doesn't work very well, but kind of it's kind of become, I don't want to say an industry standard because there's still monoliths out there, but kind of the monolith or the monolithic application is a bit of a dying breed, and Kommodity is just that. It's a giant monolith, and I've occasionally found myself, like riding my bicycle and just philosophizing about the fact that is it the right choice to build a monolith? But then, I look back at like the way that you would deploy all these microservices, and do you want a bunch of microservices to manage your critical infrastructure? Maybe
Mm.
not. Do you have different teams managing each of these services? Does it make sense for them to be microservices to begin with? And I've arrived at the kind of conclusion that doesn't really make sense to do that. But I think that's going to be a big question that we'll face when we go to KubeCon is why in the world did you decide to make this a monolith? And I think we have very good answers why we did that.
Well,
And
at the end of the so okay, maybe we can challenge each other here, because I mean the whole idea of Kommodity is this killing the bootstrap cluster, and I mean chicken and egg problem. What came first?
mm,
So let's put it let's say that we took each of the different Kubernetes services, like the Kube API, the aggregator server, the extension server, moved them into separate services. We took the attestation service for creating or for validating trust to the machines into a different service, and we took the metadata server because we don't want to be dependent on the hyperscaler metadata server. That's why we implemented our own metadata server to I mean, when the machine is trusted, we will hand out the configurations to connect to our cluster. That's the responsibility of a metadata server. We have implemented that. And we took the gRPC and made that into a separate service as well. So that now we're up to 6 different services within Kommodity.
mm,
They are all different services, all different binaries.
yeah,
How do you deploy those then?
no,
I
exactly.
mean, then you're back to then you're back to what you tried to kill with Kommodity. Then you're back to who bootstraps the cluster that runs these services.
And that's super fair, right? It's just that there's this one thing that, and I think that's the primary concern that's been nagging the back of my head is like, where does it stop to scale the monolith? Because like,
I mean,
how many clusters can we provision before this thing breaks, and how many concurrent reconciliations can we run? And maybe that's not even a concern, right? Do you have millions of clusters? Maybe not. I mean, clusters are getting bigger.
yeah.
Like one of the big hyperscalers, they basically support now up to 65,000 nodes. If you look up that specific number, you'll find out which. So it's it's really interesting to see that like you can run a lot of clusters, but is that really needed? Do you run bigger clusters? I think as long as you can cover most of the geographies, like if you want to build one in a particular country or region, or even a little bit more local than that, um, then you might be fine with the scalability that you get out of this. But I think that's the thing that part of my brain is nagging about.
Well, also nothing says that Kommodity won't ever be able to scale, right?
Yeah.
That's for sure some development that would need to be done. But for example, right now we're using it running it in Azure Container App as a Docker container. You can easily scale that. They have that feature, right? I mean, it's made to be a scalable service, so
And I
that could
mean,
be solved like
at
that too.
at the end of the day, who says a worldwide organization should only run one commodity for all their clusters? You
Mm,
could be running one commodity for development, one
Mm.
commodity for staging, one commodity for pre-prod, and one commodity for prod,
mm.
because you don't want your prod cluster details to be, I mean, to be mixed with your pre-prod cluster details. You want different access policies for getting access to prod than to pre-prod. I mean, I don't see a world where a company only runs one instance of commodity for all the different flavors of clusters that they have.
That makes me sleep better at night.
Resolved. Are there companies or people that you wish that you could have sitting at a table like this, that you wish that you could learn from and hash this out with? Are there obvious names that come to mind?
I think
I would love to sit at a table and talk to the people from Cyder Labs, which is the company behind Talos, to
Yeah.
understand how they have built Talos, because that's a really powerful tool. And as Paul also says, I mean, it's no secret that the Talos is the backbone of Kommodity. Without Talos, we would not be able to do what we do with Kommodity.
Mm. I think I would also like to talk to some of the hyperscalers to
Mm.
understand, like, is there value in having this, and kind of, because like it's direct competition to some of the big Kubernetes engines that you can get from the hyperscalers, right? And like, one dimension is it's that, but also like the hyperscalers, they started building their own operating systems as well. So suddenly, like, Telos is becoming this thing that can actually give you the competitive edge to really hurt the hyperscalers potentially. So I want to get their feedback to see, like, is there value in building this together rather than making this an like an us versus you thing. Yeah,
Yeah,
yeah.
also.
It's I think it's interesting because, right, they've seen that they know maybe a little bit more scale, right? Because they sit at the bottom of it all, um, at the bottom of the ecosystem. So it's really interesting to see, um, could something like that actually work, where we as the infrastructure community agree on, like, the way that we agree on Kubernetes, like how is Kubernetes built, that we can agree on, okay, these are the open standards that we use to kind of provision Kubernetes.
Mm.
That would be really, really powerful.